Hello everyone. Today in this web series, we will be talking at multithreading. So multithreading is an important concept and every developer or every programmer should be familiar with this term multithreading. So the reason why this multithreading is very popular because it reduces or minimizes the ideal time of a resources. So if there are multiple threads, and if there is proper scheduling of this thread, then the resources will be ideal for a very less amount of time. In this way, you will be able to execute the entire program in a very less amount of time. So this is why multi-threading is an important concept, and you should be familiar with it. So in this web series, I will be demonstrating you how multi-threading works with the help of a code. But before diving into the coding section, we first should be familiar with the terminologies of multi-threading. So with the help of this picture, I want to demonstrate how multi-threading works. So basically, there is always a main thread in your program. I'm not sure, are you aware of this thing or not? But with the help of a main thread, you will be creating a number of thread as per the requirement of your code or of your application. So in this picture, there are total number of 3 threads, and these thread 1 and thread 2 are being created from main thread. So what basically thread is? Thread is a unit of process. Like meter is a unit of length. Similarly, thread is a unit of process, and we can call it as a sub process. So there is a process, and you have divided the process into various sub process, and the various sub process have been parallelly executing. So this will help you to better understand what the thread is all about. So if you are a Java programmer and you have been coding in Java for a while, so you have used thread knowingly or unknowingly, because every program in Java by default uses thread. To support this statement, whenever there is an error in your main method of your class, there will be an exception, that is exception in thread main. So what this statement wants to demonstrate you is like in the thread that is main, there is an exception. So always there is a thread in the main method of your class. So the main that means main is the thread. So by default, all Java programs is of thread. So basically, there are 2 ways to use multi-threading in Java. The first one is by extending thread, and the second one is through implementing runnable. So reason why we have introduced implementing runnable is because Java does not support multiple inheritance. So in some cases, when you want to have multiple inheritance, by extending thread, you won't be able to do so. But with the help of implement runnable, you are able to do. That's why runnable runnable is been introduced in Java. So over here, I will be showing you a simple Java code, and by following this code, we will try to achieve multi-threading. So this is an over here what I have done is that I have created a class that is multi-thread intro, and this is our main class. And from the main class, I have created an object of 2 different classes, that is prompt message and prompt response. So this is prompt message, and that is one is the prompt message, that is prompt response. So by the name of the class, I have printed the same name in the print section. Over here, I have done the same like a prompt response. So I've kept the name prompt response, so you get a better familiarity which class is being executed. So I have created an object of both the classes, and I have called the respective methods that are present in both the classes. So I will be executing this. So this is what the response I have got. But I think so you haven't got what I am trying to do. So basically what I am trying to do is like I am iterating a loop, and then I am printing out the response. So I will try to delay it by a few seconds. So how I want to delay it is by using thread.sleep. So thread.sleep pauses your execution. So this will be in a millisecond, that is 10 raised to minus 3, so it's 0.5 second. So now you will get a better view of what the thing is happening. So it will take time, and in this way it has been executed. Prompt message, prompt message, prompt message. As I have called an object m1 that is of class prompt message, that's why the prompt message has been displayed for 5 times. And similarly, the r1 method of class prompt response, that's why prompt response has been displayed for 5 times. But this is not what we all are looking for. We all want synchronization, and so we want prompt message, and then we want to display prompt response, so that we can get to know how multi-thread is working over here. So coming to as I have told you earlier, this is the way that we can implement multi-threading, that is through thread, and the second one is through runnable interface. Now jumping to the part number 2 of our multi-threading. As I have told you earlier, main is a thread already, and it is the master of our program. So from the master of our program, we can create multiple thread as per our requirement. So in the previous program, what I have shown you, that with the help of thread.sleep, I can hold the process for the amount of time that we are looking forward. Now we want to make the thread run parallel. So how we can do is by extending thread. So by extending thread, we can do so. I will be showing you a code that will help you to understand. So I have used the similar example that I have shown you earlier. Just I've changed the name of the classes, that is show message, and I've displayed the show message for the class show message, and for the class show response I have displayed it show response. But what the new thing that I have introduced in this code is that I have extended thread. So I am using extends thread to implement a multi-threading. So what it will do is, like, I will show you over here, that is show message, show response, show message, show response, show message, show response, show message, show response. So you can see that I have created two threads. Two threads are executing parallelly, and that is why I am getting a response of show message, then show response, then show message, then show response. So how I am able to do is by using extend thread class. So one more important thing, as I have let you know that I have used thread.sleep and thread.sleep over here, that is 500 millisecond and 500 millisecond, and I have again used thread.sleep over here. The reason why I have used so is because if I don't use thread.sleep between two threads, then this will happen: show message, show response, show response, show message. So they are executing. So multi-thread is being executed, but they are not executed in a synchronized manner. The reason why, because in operating system you must have heard the term of process scheduler. So there are process scheduler is unable to identify which process to allocate, which process should be allocated resource first, and because both the process are having priority of same level. As you can see that I have not set any priority, so by default the priority of these two threads are same, so it is selecting thread by default. So in order to avoid this, what I am doing is, like, I am making the thread sleep, so I am creating a space, a pause between the two threads. So once one thread is being executed, then only the second thread is being executed. One more important thing that you should know, and I'm sure that you won't be knowing it, is use of thread.sleep in a proper sense. what I mean to say is like, if I increase the time between the two thread uh, to a greater extent. What I mean to say it like, over here there is a 50 microsecond gap time difference between M1 thread and M2 thread. So M1 and M2 are getting appropriate time in order to synchronize themselves. So if I increase the time to 5000, that is greater than this 500 and 500 of this, then our objective is not met. Show message, show message, show message, then show response, show response, show response. The reason why this is happening is because I have created a thread dot start. What it is doing is, it is calling run method. So I am overriding this run method, and I have used this sleep method. So this has been executed, but this method is still not being executed. The reason why, because the time is so large that this entire process has been completed, yet this dot sleep is on process, and once it is done, this thread R1 gets a like is being initialized, and in this way show response is being executed. So you must be aware of what the time that you are creating between two processes. So if it is greater than or equivalent to this, it will create a trouble for you. So you must uh, pay attention toward the time that you are allocating between one thread and another thread. So it must be less than what you are allocating in the true thread. So I have kept it 50, and in this way the synchronization is been achieved. So message, so response, so message, so response, and in this way we are able to do it. Okay, one more thing that I forgot to tell you is like, when I extend thread, so extend thread has a method that is run. So we need to override this method. So we are overriding this method. This has been taken from a thread class. So start will automatically call thread, will call run method of a thread class. So just I have overridden the thread class over here, and the business logic is same as the previous example. So this is our scheduler, and as I've told, like there are two threads, and our scheduler is unable to find the difference between the two because both are of the same priority. So it selects them in a random order. So if you want to avoid this circumstances, then you need to create a space. What I mean to by saying space is that you need to create a time difference between M1 and M2 so that they can be executed parallelly. Now another way through which you can implement multi-threading is through runnable interface. So when I see runnable interface, so runnable interface is a functional interface. Now your functional interface, you must be excited to know. So runnable interface. So runnable interface is a functional interface, as I've said you earlier, and it has only one class, that is run. So runnable does not have a start method. Now what should I do to run the thread? So what we do is like we create a thread object and call start method, but the program arises over here again that when we call the thread method, it called the start method of itself, not of runnable interface. So what we will do that we will bind the object with runnable. So I will show you how we are doing it. So this is the way that we are doing. The same thing is that if I display message is the class, then I am printing display message, and if display response is the class, then I am printing display response, so that you can better understand which class is being executed. In this way, so in the main class, you can create a method of each class by their name, but over here what I am doing is that I am creating a reference of interface that you can see over here, and creating an object of class. So as I've told you earlier that runnable does not have a start method, therefore we need to create a thread. So I have created a thread and I have binded the object of this one with thread, and I have done this implemented the same logic that I have done in the in the previous code. So once I execute this code, I got a synchronical order, display message, display response, display message, display response, and my objective has been fulfilled. So one thing that you should keep in mind or take away from this code is that you can create a reference. You can do also it by creating a reference of interface and creating an object of class. So I hope you understand it. And one more key take is that runnable does not have a start method. So even if I call it, it will not call the run method. So what I have done is that I have created the thread and then I have binded it with the runnable. So in this way, I am able to execute it. So now coming to the fourth part, that is Lambda expression. And so as I told you earlier that runnable is a functional interface, so Lambda can be introduced into it. So now I will be showing you how runnable have been written over here. So I have created, okay, so we cannot instantiate object from interface. We can only do it with the class. So here we are using a anomalous class. So this is the anomalous class that I have created. So there is no two different classes. Now there is a single main class, and in the main class, with the help of an anomalous class, I am creating an object. But my objective is not to show you the implementation of anomalous class. I want to show you how with the help of Lambda expression, we can execute multi-threading. So Lambda expression has been introduced in Java 8. So it is a very new concept because in Java 8, functional programming has been introduced. So till now, before Java 8, we were doing programming in object-oriented analysis or a paradigm. But now they have introduced a functional paradigm. So it what functional paradigm is able to do it, like it have reduced your code line to a greater extent. So in this way the code is now more readable, so one can easily read what the code is all about. This is how I have done by anomalous class, but as I told you, my objective is not to show you how this anomalous class works. So what I have done is that I've used this a Lambda expression. So Lambda expression is a stream expression. So this is what I have done over here. Again, I have binded an object of runnable over here with it, and I have executed. So when I execute, the similar output will be displayed. So the key takeaway is that we can use anomalous class as well as we can use Lambda expression. So in Lambda expression, you don't need to write a run method. So over here you can see you don't need to write run. Just you need to write runnable. You need to create an object. You need you can so if there you can pass a parenthesis brackets, and then you can pass curly parenthesis over here, and you can write the business logic over here. Similarly, I have done for different object, and I have created a thread class, and I have binded my runnable with this thread class, and I have called the start method of the thread, and I have provided us time difference between both the thread, so that it can have a synchronical order, or the thread can be synchronized in a better sense. So that's all for from this part. In the next part, we will be jumping on to the producer consumer problem. So before jumping to producer consumer problem, you must be well known with the concept, and you must code this example by yourself. So I will be posting this link down to the video, so that you can refer the code from here. So I will end you from now over here. Thank you for being with me. I hope that I'm able to make your life better, and create a more generalized approach toward recording your multi-thread.